Good afternoon, Year 4, and welcome to your second geography lesson of the year. So last week we looked at the structure of the Earth and tectonic plates and their movements. And this week we're going to be looking at earthquakes and some of the physical effects that earthquakes can have. So let's get started. So our question this week is, what are earthquakes and what effects can they have? First of all, we're going to begin with our knowledge quiz. So same as last week, grab a notebook if you want to jot your answers down, or you can answer it out loud. It's completely up to you. If you need a bit more time after I've read the question, just pause me and then you can come back to find out what the answer is. Okay, so our first question is, which of the layers of the Earth is liquid? So we have the inner core, the outer core, the mantle, or the crust. So yes, you are absolutely right if you said the outer core. The outer core is the only layer which is liquid. The others are not. Question number 2. The outer core is the hottest layer of the Earth, and it's true or false? Yes, well done if you said false. Even though it's a liquid and the inner core is a solid, the inner core is hotter. The reason it's a solid is because all of the other layers have so much pressure onto it that it is a solid and not a liquid. So it's the inner core which is the hottest layer of the Earth. Question number 3. At a divergent plate boundary, two tectonic plates either move towards each other, pull away from each other, or slide past each other in opposite directions. So think back to your actions from last week and see if you can remember. So yes, you're absolutely right if you said at a divergent plate boundary, two tectonic plates pull away from each other. So our action for divergent was divergent. It is at a convergent boundary where the two plates move towards each other, and at a transform plate boundary where two plates slide past each other in opposite directions. Question 4 is from our unit on the Romans. So before the Romans invaded Britain, where did the Celts used to bathe? So I've either got in rivers, in public baths, in the village square, or in their houses. So yes, you're absolutely right if you said in rivers. They didn't bathe in baths. That was what the Romans came and introduced to Britain. And they didn't bathe in the village square, and they were not lucky enough to have baths in their houses. Which is the longest river in the world? So this is from your unit in geography last year on rivers and mountains. See if you can remember. You've got options of the Ganges, the Amazon, the Congo, or the Nile. So yep, well done if you remembered. It is the River Nile. Well done on completing your knowledge quiz this week. Okay, so before we move on to this week's learning, we're just going to quickly recap what tectonic plates are. So the crust that we live on is split into large plates floating on the mantle. Heat rises up from the mantle, which makes the plates move ever so slightly. We can't feel it, it is very, very slight. The white lines on here show you the plate boundaries, and as we can see, the plates are all different sizes and they kind of slot together like a jigsaw. Now let's have a look at a thing that we call the Ring of Fire. So the Ring of Fire is a zone around the Pacific Ocean where most earthquakes and volcanoes occur, and it traces the boundary of many tectonic plates. So again, as we can see on this diagram, the dashed lines represent the plate boundaries, and the Ring of Fire, which is in the red, highlights that it is around many plate boundaries. So 90% of Earth's earthquakes and 75% of Earth's volcanoes are on the Ring of Fire. So the Ring of Fire has such a large amount of earthquakes and volcanoes as this is where most movement of tectonic plates occurs. So as you can see on the ring, it's got many plate boundaries, and as we know, that's where much of the activity that creates earthquakes and volcanoes occurs. So the Ring of Fire is a really perhaps dangerous place to live because there can be lots of earthquakes and, as we've said, lots of volcanoes. So let's have a look. What actually is an earthquake? We probably all have some idea, but what causes an earthquake? So we've got 5 steps that create our earthquake. Step number 1 is that two tectonic plates are moving past each other at a plate boundary. It's usually at a transform boundary. One of the plates gets stuck, so it gets slightly stuck against the other plate. Because the plate is stuck, pressure builds up whilst it tries to free itself. So it's giving a bit of extra energy to try and unjam itself, and therefore pressure begins to build up. When the plate manages to become unstuck, the pressure is released in a wave of energy called a tremor. So the plate pushes and it finally gets through, but it's done a big push to get through. So it creates quite a jerky, bigger movement that we call a tremor. And the tremor is what causes an earthquake. So the tremor begins to shake the ground, and this creates an earthquake. So first thing that happens is that tectonic plates are moving past each other at a plate boundary. 2, one of the plates gets stuck. 3, because the plate is stuck, pressure builds up whilst it tries to free itself. 4, when the plate manages to become unstuck, the pressure is released in a wave of energy called a tremor. 5, the tremor is what causes an earthquake. Okay, let's see how well we can remember these. We've got the first picture here, which just tells us that two tectonic plates are moving past each other at a plate boundary. Step number 2, see if you can remember. Yes, well done. One of the plates gets stuck as it's moving by. Step number 3, see if you can remember what happens next. Yep, so after the plate has got stuck, it starts to use more energy to try and get free, so pressure builds up, as we can see by this red dot, showing us that pressure builds up. Let's go on to step number 4, see if you can remember what's happening here. Yep, that's right. In stage number 4, the plate manages to get free and the extra pressure creates a tremor. In step number 5, yes, the tremor creates an earthquake. Well done, well remembered. So your first activity that you can either complete on the sheet or you can draw off the table, like just below, just down here. You just need to correctly order the events that lead to an earthquake. So I've mixed up the events and I've given them each a letter. So you just need to decide which is the first event and pop the letter into the box and go through the different stages. So pause me now and complete this activity. Okay, welcome back. Well done for completing that activity. Let's check if you got the correct answers. So here are your answers. You can mark it yourself. So stage 1 was B, which is that tectonic plates moving past each other at a plate boundary. Step 2 was E, which is that one of the plates becomes stuck. Stage 3 is A, which is that because the plate is stuck, pressure builds up whilst it tries to free itself. Step 4 was D, which is that when the plate manages to become unstuck, the pressure is released in a wave of energy called a tremor. And step 5 is C, which is that the tremor causes an earthquake. So well done if you got these in the correct order. Okay, now we know what an earthquake actually is and how it occurs, let's look at what some of the physical effects of an earthquake are. So, physical effects are those that impact the natural environment. So it's effects that happen to the landscape and the oceans. The first effect that we're going to look at of an earthquake is an aftershock. My turn, your turn. Aftershock. So an aftershock is a smaller earthquake which comes after a large earthquake. So the earthquake's called the main shock, and then we get a lot of smaller aftershocks that come after the main earthquake in the same area. And there can be more than one aftershock. There's often lots. And they can come, as we can see on this little graph, they can be varying amounts. So the first one you might get might be quite big, and you might get a smaller one, it might get bigger again. But your first physical effect of an earthquake is aftershocks. The second physical effect that might occur after an earthquake are landslides. My turn, your turn. Landslides. So during an earthquake, the land moves. So on slopes, soil and rocks begin to roll down, as we can see in this picture. This picture is from the aftermath of an earthquake in China in 2010, which killed 1,471 people. So it was quite a severe earthquake. And as you can see, it's not necessarily the shaking of the ground which kills people. It's the after effects, like this on this slope. We can see that lots of soil and rocks began to roll down, and that will have damaged houses and properties or maybe hit people. So landslides are the second effect of earthquakes. Our next effect is avalanches. So in cold places, the tremors from an earthquake can make lots of snow and ice slide down a slope, which causes an avalanche. So this is showing us an avalanche that occurred on Mount Everest in 2015. So as you can see, lots of snow and ice began to tumble down the mountains. And it can be quite fast and quite a lot of ice and snow. So the worries of an avalanche are that if it reaches towns and cities, if a lot of snow falls, obviously it will eventually melt, and this could cause flooding. That could be quite severe. It could also obviously hurt people if a lot of snow and ice are falling down at once, and it could damage buildings and houses as well. The next physical effect of an earthquake are fires. So earthquakes cause fires as the shaking of the ground can cause gas pipes to explode. So obviously in our houses, we all have electricity and gas, but if an earthquake were to happen, the ground would start to shake, and this could make the pipes explode. Now, this often happens sadly during earthquakes, which can cause very large fires. So this is a photo from an earthquake in Japan, which was very severe in 2011. Most of your parents will probably remember this. And the death toll in this earthquake was 15,880. Now, obviously, there's lots of effects that fires can have and risks it can pose to people. It can burn down buildings, it can cause loss of life. The inhalation of smoke definitely isn't good for people. So fires is a very dangerous effect of earthquakes. The next effect of an earthquake is something called a tsunami. My turn, your turn. Tsunami. So if the earthquake happens beneath the ocean, it can create a series of huge waves called a tsunami. So the tremors from the tectonic plate cause a giant wall of seawater to form. So the ocean floor shakes and it creates a massive wave to form, which hits the coast as a long, tall wave. So again, it is an absolutely giant wave which comes rolling over. It can flood towns and cities. It can obviously wash people out to sea. It can cause severe flooding. So we're just going to have again a look at the earthquake that happened in Japan in 2011. So tsunami can create a lot of loss of life and a lot of debris. Obviously, we can see in this picture over here, it's so powerful, the amount of water that it manages to wash cars and even planes to different locations. We can see here in this picture, part of the tsunami with a giant wave rolling over, coming crashing into the city. In this bottom picture, we can actually see as well where the tsunami's come and it's flooded all of these houses, but there was also still a fire occurring from a gas pipe or something which has managed to burst under the ground. And as you can see though, even though they are obviously very severe, survivors do always manage to somehow get out of these situations. There is always hope. Okay, so we're just going to quickly, before we move on to your last activity, just review the physical effects we've talked about. So we had aftershocks, we had landslides, we had avalanches, we had fires, and we had tsunamis. So for your second activity today, I would like you to create a poster to warn people about at least 2 of the physical effects that might happen after an earthquake and what damage could happen. So I've included the link to this book again on your home learning sheets that we looked at last week. So if you'd like to do some more research on there, you can find out. Or you can use the information that we've just gone through. You can rewind this video if you want to re-listen to parts of it. So here's an example that I did, and I'm sure that yours are going to be much better, probably more colourful. So on mine, I tried to do some pictures. They're not great, but I've done some pictures of the effects that can happen. I've written about what happens, so during an avalanche, for example. I've written that in cold places, tremors from the earthquake make snow and ice slide down the mountain. And then I've also listed some of the risks to people. So my risks on my avalanches section of my poster says you might get buried under lots of snow. A large amount of snow could land on your roof, and which could make it collapse. And the ice will eventually melt, which could cause some flooding. So it'd be great if you could include some pictures. It'd be great if you could draw these. If you could tell me what happens during this physical effect. So you could tell me what happens during a tsunami or a landslide or an aftershock. What the risks are, so what can happen because of this effect. And feel free to include any other information that you might be able to research on one of these topics. It's really interesting to see. So as I've said, if you need to go back and look at any of these physical effects of an earthquake, then that is great. Just be careful if you're researching not to include any human effects, as these are different physical effects, and we'll come back to these next week. All right, good luck with your posters. I can't wait to see what you produce. And I will look forward to seeing them on Seesaw. I hope you enjoyed this lesson and that you all feel confident now about what an earthquake is and some of the physical effects that can happen during it. Bye.